Welcome back, students. Today in this session, we will continue to solve the questions in the given exercise of chapter 13, surface areas and volumes. So exercise 13.3, question number 3. Curved surface area of a cone is 308 centimeters square and its slant height is 14 centimeter. Find Roman number 1, radius of the base, and Roman number 2, total surface area of the cone. So exercise 13.3, question number 3 solution. In the question, it is given that the curved surface area of the right circular cone is 308 centimeters square and that of slant height is represented by L, letter L is equal to 14 centimeter. So in Roman number 1, we are to find the radius of the base, and in Roman number 2, we are to find the total surface area of the cone. So for Roman number 1, we know that the curved surface area, let us first write this statement. Let R centimeter be the radius of the base. Then we know that the curved surface area of a cone is given by pi r L. This implies curved surface area is 308 centimeters square. The value of pi is 22/7. We will write r as it is, and the value of L is 14 centimeter. So from this equation, we can easily find the value of R. So let me find the value of R. R is equal to 308 multiplied by 7 and then divided by 22 into 14. Let's simplify this and we will get the value of R. So this 2 and then 308 divided by 2, we will get 154. 154 divided by 22 is 7. So the value of R is equal to 7. Hence, the radius of the base is 7 centimeter. Now for the second part, we are to find the total surface area of the cone. So the total surface area of the cone is given by total surface area equal to, is given by the formula pi r within bracket L plus R, which is equal to, the value of pi is 22/7, the value of R is 7, and the value of L 14 plus R is 7. This will be centimeter square, equal to 7 and 7, so 22 into 21 centimeter square, which is equal to 462 centimeter square. Next is exercise 13.3, question number 8. A bus stop is barricaded from the beginning part of the road by using 50 hollow cones made of recycled cardboard. Its cone has a base diameter of 40 centimeter and height 1 meter. If the outer side of each of the cone is to be painted and the cost of painting is rupees 12 per meter square, what will be the cost of painting all these cones? Use pi equal to 3.14 and take root over 1.04 equal to 1.02. So exercise 13.3, question number 8 solution. Let us first write down the given information. So here diameter of the cone is equal to 40 centimeter. So radius of the cone will be represented by the letter R is equal to 40 by 2 equal to 20 centimeter. And the height of the cone is given as 1 meter. Now let us find slant height. Slant height represented by letter L is equal to under root R square plus H square. R is 20 centimeter and H is 1 meter, so they are of different units, so we'll convert them into the same unit. So let us convert this R, that is the radius, into meter. So 20 centimeter will be equal to 0.20 meter. So substituting the value of R and H in this equation, we will get under root R square is 0.2 square plus H square will be 1 square. This will be equal to 0.2 square is 0.04 plus 1 under root. This is equal to under root 1.04. In the question, it is mentioned that we are to use the value of under root 1.04 as 1.02. So this will, the slant height will be equal to 1.02 meter. Now let us first find the curved surface area of one cone. The curved surface area of a cone is given by the formula pi r L. So this will be equal to, also in the question it's mentioned that we are to use the value of pi as 3.14. The value of r is 0.2 and that of L is height, that is slant height, is 1.02 meter. Next, let us find the curved surface area of 50 such cones. So the curved surface area of 50 cones will be equal to the curved surface area of one cone multiplied by 50. So this will be equal to 50 into 3.14 into 0.2 into 1.02. This will be meter square. Multiplying all this, we will get the value as 32.028 meter square. So for the last part of the equation, we are to find the value of the cost of painting the 50 cones. So the cost of painting per meter square is given as rupees 12. So the cost of painting 50 cones will be multiplied by the curved surface area of 50 cones multiplied by rupees 12. So cost of painting 50 cones will be equal to rupees 12 multiplied by the curved surface area of 50 cones, that is 32.028. This will be equal to rupees 384.34, correct to the 2 decimal place. Next, exercise 13.4, question number 4. The radius of a spherical balloon increases from 7 cm to 14 cm as air is being pumped into it. Find the ratio of surface areas of the balloon in the two cases. So exercise 13.4, question number 4, solution. So in this question, we are asked to find the ratio of a balloon whose radius is 7 cm to the same balloon when its ratio becomes 14 cm as air is being pumped. The required ratio, therefore, the required ratio is equal to the surface area of the balloon, the surface area of the balloon when radius is equal to 7 centimeter by surface area of the balloon when the radius is 14 centimeter. When the radius is 14 centimeter. So earlier we know that the surface area of a sphere is given by 4 pi r square. So we are going to use this simple formula to find the surface area of this two balloon when one is of radius 7 centimeter and the other one is of 14 centimeter. So the surface area for the first case will be 4 pi r square. That is, the value of r is 7 centimeter. There will be 7 into 7. And for the second case, the surface area will be 4 pi r square into, here r is 14, so there will be 14 into 14. Since it is a radius, it will be a unitless, since ratio has no unit. This is equal to 4 pi will get cancelled. 7 2 times is 14 and 7 2 times is 14. So this will be 1 by 4. This is equal to 1:4. So the required ratio is 1:4. Next, exercise 13.4, question number 7. A hemispherical ball is made of steel 0.25 centimeter thick. The inner radius of the ball is 5 centimeter. Find the outer curved surface area of the ball. So exercise 13.4, question number 8, solution. Here the thickness of the ball is equal to 0.25 centimeter and the inner radius of the ball is 5 centimeter. Therefore the outer radius will be equal to the sum of inner radius plus the thickness. So it will be 5 plus 0.25 centimeter. So now let us find the outer curved surface area of the ball. The ball is in the shape of hemisphere, so we are going to use the formula 2 pi r square. So this will be equal to 2 into the value of pi is 22 by 7 and the value of r is, this will be equal to how much? 5.25 centimeter. So this will be 5.25 square. This is equal to 2 into 22 by 7. 5.25 square can be written as 5.25 into 5.25. So 5.25 divided by 7 will be 0.4 0.75. This will be equal to, multiplying all this, we will get 173.25 centimeter square. So the outer curved surface area of the ball will be 173.25 centimeter square. Next, exercise 13.4, question number 9, solution. A right circular cylinder just encloses a sphere of radius r. Find the surface area of this sphere, curved surface area of this cylinder, and Roman number 3, the ratio of the areas between Roman number 1 and 2, that is the ratio between surface area of the sphere to that of the curved surface area of the cylinder. So exercise 13.4, question number 9, solution. So in the question it is mentioned that a right circular cone just encloses a sphere of radius r. So a sphere of radius r. So radius of the sphere is r. So the radius of the right circular cone will also be r, and the height of the right circular cone will be equal to the diameter of the sphere, that is the height will be equal to twice r. That is the diameter of the sphere. So now for the first part of the question, that is you are asked to find the surface area of this sphere. So that will be equal to surface area of this sphere will be equal to 4 pi r square. And for Roman number 2, there is the curved surface area of the cylinder. So to find the curved surface area of the cylinder, we need to know the radius of the base and that of the height. So looking at the figure, the radius of the base of the right circular cone is r, and that of the height of the right circular cylinder is twice r. So radius of the cylinder is equal to r, and the height of the cylinder is equal to twice r. And we know that the curved surface area of a cylinder is given by the formula twice pi r h. So substituting this value, we will get the curved surface area of that given cylinder. So 2 into the value of pi, let me write the value of pi as it is, and the value of r is r, and the value of height, that is h, is twice r. So the curved surface area of this cylinder will be 2 into 2, 4 pi r square. Now for the third part, that is we have to find the ratio of this two, that is the surface area of the sphere to the ratio of the to the curved surface area of the cylinder. So for Roman number 3, the required ratio is equal to 4 pi r square divided by 4 pi r square, that is 1 by 1, and the ratio is 1:1. So the required ratio is 1:1. Next exercise 13.5, question number 4. Find the cost of digging a cuboidal pit 8 meter long, 6 meter broad, and 3 meter deep at the rate of ₹30 per meter cube. So exercise 13.4, question number 4, solution. So the length of the pit is, let length be represented by the small letter L. Of the pit is 8 meter, and the breadth of the pit is 6 meter, and the height of the pit, that is the depth of the pit, is given as 3 meter. So let us find the volume of the pit. Volume of the pit equal to the volume of a cuboid is given by the formula length into breadth into height. So this will be equal to 8 into 6 into 3 meter cube, equal to, multiplying all this, we will get 144 meter cube. So the cost of digging the pit per meter cube is cost of digging per meter cube is given as ₹30. So the total cost of digging the pit will be cost of digging the pit will be equal to rupees 30 multiplied by the volume of the pit, that is 144. This will be equal to rupees 4,320. So the total cost of digging the pit is rupees 4,320. Next, exercise 13.4, question number 8. A solid cube of side 12 centimeter is cut into 8 cubes of equal volume. What will be the side of the new cube? Also find the ratio between their surface area. Exercise 13.4, question number 8, solution. So in the question it is mentioned that a bigger cube of side 12 centimeter is cut into 8 smaller cubes, and we are to find the length of the side of the smaller cube. So here let L be the length of a side of the bigger cube, which is equal to 12 centimeter. So volume of the bigger cube, will be equal to L cube, that is 12 cube centimeter unit. The unit will be centimeter cube. 12 cube is equal to 1728 centimeter cube. So the volume of the bigger cube is 1728 centimeter cube, and that is cubic centimeter. Now the volume of one smaller cube will be equal to, since the bigger cube is cut into 8 equal smaller cube, the volume of one smaller cube will be 1728 divided by 8 centimeter cube. This will be equal to 216 centimeter cube. So the volume of a smaller cube is 216 centimeter cube. Now let a centimeter be the length of a side of the smaller cube. Then by question, according to the question, we will get a cube equal to 216. This implies a equal to cube root of 216, which is equal to 6. So the length of a side of the smaller cube will be 6 centimeters. So therefore side of the smaller cube will be, smaller cube is 6 centimeter. And now for the second part of the equation, that is, we have to find the ratio of the surface area of the bigger cube to the surface area of the smaller cube. So the required ratio will be equal to surface area of the bigger cube to the surface area of the smaller cube. Equal to surface area of the bigger cube will be given by 6L square, and that of the surface area of smaller cube will be given by 6A square, which is equal to 6 into L square is, the value of L is 12, so I can write 12 into 12, and 6 into the value of A is 6, so 6 into 6. So this 6 and 6 will cancel each other. 12 divided by 6 is 2, and this also 2. Now this will be 4 by 1, that is the required ratio is 4:1. Next, exercise 13.6, question number 2. The inner diameter of a cylindrical wood pipe is 24 centimeter and its outer diameter is 28 centimeter. The length of the pipe is 35 centimeter. Find the mass of the pipe if 1 centimeter cube of wood has a mass of 0.6 gram. So exercise 13.6, question number 2, solution. In the question, it is given that the inner diameter of the wooden cylindrical pipe is 24 centimeters. So the inner radius of the pipe represented by the small letter r will be equal to half of the diameter, that is half of 24. So 24 by 2 centimeter equal to will be 12 centimeter. And the outer radius will be represented by capital R. Outer diameter is given as 28 centimeters, so the outer radius will be half of the 28. So the outer radius will be 14 centimeter. And the height of the cylindrical pipe represented by small h, which is mentioned as the length of the pipe is 35 centimeter. And we have to find the mass of the wood used in making the cylindrical wooden pipe. So to find the mass of the wood used, first we will find the volume of the wood used. Volume of the wood used. This will be equal to the volume of the cylindrical pipe for the outer radius minus the volume of the cylindrical pipe for the inner radius. So that will be equal to pi capital R square h minus pi small letter r square h. This is the volume of the pipe for the outer radius, and this is the volume of the pipe for the inner radius. And the difference between these two will be the volume of the wood used. Then we take pi and h as common, so within bracket will be capital R square minus small letter r square. This will be equal to the value of pi is 22 by 7, h is 35, capital R 14 square minus and then 12 square. This is equal to 22 into 5, and 14 square minus 12 square is equal to, let us use the identity a square minus b square to find the value of 14 square minus 12 square. So this will be equal to, the identity says a square minus b square is a plus b whole into a minus b. So 14 plus 12 will be 26 into 26 into a minus b, that is 14 minus 12 will be 2. So the volume of the wood used will be 22 into 5 times into 26 into 2 times. This will be equal to, since this is volume, the unit will be centimeter cube. Multiplying all this, we will get 5720 centimeter cube. This is the volume of the wood used. Now for the mass of the wood, in the question it is mentioned that 1 centimeter cube of wood weighs 0.6 gram. So total mass of the wood will be 5720 multiplied by the 0.6 gram. This will be equal to 3432 gram, which is equal to 3.432 kg. So the mass of the wood is 3.432 kg. Next exercise 13.6, question number 8. A patient in a hospital is given soup daily in a cylindrical bowl of diameter 7 centimeter. If the bowl is filled with soup to a height of 4 centimeter, how much soup the hospital has to prepare daily to serve 250 patients? So exercise 13.6, question number 8, solution. So in the question, it is mentioned that in a hospital, soups are served in cylindrical bowl of diameter 7 centimeters. So the diameter is given as, diameter is equal to 7 centimeter. Therefore, the radius of the cylindrical bowl will be equal to 7 by 2 equal to 3.5 centimeter. And the level of soup in the bowl is 4 centimeters. So the height for the height of the cylindrical cylinder for which we are going to find the volume is 4 centimeters. So the level of the soup will be the height of the cylinder for which we are going to find the volume of the cylinder. So which is equal to 4 centimeter. Now let us find the volume of the soup. Volume of the soup served per bowl or per patient, which will be equal to pi r square h equal to 22 by 7 into 3.5 into 3.5 into the height is 4. This is equal to 3.5 divided by 7 is 0.5 and 22 multiplied 0.5 is 11. So 11 into 3.5 into 4 volume of the cylindrical bowl. So this will be centimeter cube. Multiplying this, we will get 154 centimeter cube. This 154 centimeter cube is the capacity of one bowl. Capacity of soup for one patient. This is the capacity of soup served to one patient, and now we are to find the volume of soup for 250 patients. So volume of soup for 250 patients equal to 154 multiplied by 250 centimeter cube. This is equal to 38,500 centimeter cube. So the hospital has to prepare a quantity of 38,500 centimeter cube of soup. Next exercise 13.7, question number 7 and 8. So in question number 7, it is mentioned that a right triangle ABC with sides 5 cm, 12 cm and 13 cm is revolved above the side 12 cm. Find the volume of the solid so obtained. And in question number 8, if the triangle ABC in the question 7 above is revolved above the side 5 cm, then find the volume of the solid so obtained. Find also the ratio of the volumes of the two solids obtained in questions 7 and 8. So exercise 13.7, question number 7, solution. In the question, it is given that a right triangle ABC in which the sides are of 5 cm, 12 cm and 13 cm. This is the triangle ABC in which the sides are 5 cm, 12 cm and 13 cm. And this triangle is revolved above the side 12 cm, and we are to find the volume of the solid so obtained. So if we revolve this right triangle ABC above the side 12 cm, we will get a right circular cylindrical cone with radius as 5 cm and height as 12 cm and slant height as 13 cm. So this cone will have radius as 5 cm, height as 12 cm and slant height as 13 cm. So the solid so formed is a right circular cone, and we have to find the volume of this cone. So here radius of the cone r is 12 cm 5 centimeter, and height of the cone will be 12 centimeter, and slant height will be 13 centimeter. And the volume of the cone so form will be equal to, the volume of the cone is given by 1 by 3 pi r square h. So this will be equal to 1 by 3 into pi. The value of r is 5 square into h is 12. So 12 divided by 3 is 4. 5 square is 25. 25 4 times is 100 pi. Let me keep the value of pi as it is. So the volume of the cone is 100 pi centimeter cube. This is the solution for question number 7. Now let us move on to question number 8. So for question number 8, in question number 8, it is mentioned that this same triangle is revolved around the side of the 5 centimeter. Now in question number 7, the triangle is revolved around the side 12 centimeter. Now in question number 8, the same triangle is revolved around the side 5 centimeter. So let me draw the figure. So this is the right triangle ABC. Right triangle ABC. This is the side which is 5 centimeter long, and this is 12 centimeter, and this is 13 centimeter. So if we rotate the triangle, right angle triangle at the side 5 centimeter, this 5 centimeter will be the height of the cone so formed. So a cone will be formed like this. A right circular cone will be formed like this, where 5 centimeter will be the height of the cone, 12 centimeter will be the radius of the cone, and 13 will be the slant height of the cone. So here the radius is equal to 12 centimeter and the height of the cone will be 5 centimeter. So taking account into this, we'll find the volume of the cone so forth. Volume of the cone for question number 8 will be equal to 1 by 3 pi r square h equal to 1 by 3 pi. R is 12 square and the value of h is 5. So this will be equal to 1 by 3 pi into 12 into 12 into 5. This is centimeter cube, centimeter cube. This will be equal to, this will be 4 times 5 4 times is 20. 12 into 20 will be 240. So the volume will be 240 pi centimeter cube. Now let us find the ratio between ratio of the volume of these two cone. So the required ratio will be, hence the required ratio is equal to, the first volume is 100 pi by the second volume 240 pi. Pi will cancel, and after taking out a common factor, we will get 5 by 12, dividing both sides by 20, both numerator and denominator by 20. So the required ratio is 5:12. Next exercise 13.8, question number 7. Find the volume of a sphere whose surface area is 154 centimeters square. So exercise 13.8, question number 7, solution. Given surface area of the sphere is given as 154 centimeter square. So let r be the centimeter be the radius of the sphere, be the radius of the sphere. To find the volume of the sphere, we need to find the radius of the sphere. So let us find the radius of the sphere from the given surface area. So the surface area of a sphere is given by 4 pi r square. This will be equal to 154. This implies the value of pi is 22/7. So 4 into 22/7 into r square is equal to 154. This implies r square equal to 154 into 7 divided by 4 into 22. Here 154 divided by 22 is 7. So this implies r square is equal to 7 times 7 into 7 is 49/4. This implies r equal to under root 49/4. That is 49 is 7 square and 4 is 2 square. So the value of r will be 7/2. So the radius of the sphere is 7/2 centimeter. Now let us find the volume of the sphere. So volume is equal to, given by the formula, 4/3 pi r cube. So 4/3 into 22/7 into 7/2 cube. This will be centimeter cube. So after simplification, we will get 179 whole number 2/3 centimeter cube. So the required volume of the sphere is 179 whole number 2/3 centimeter cube. Next, exercise 13.8, question number 8, solution 8. A dome of a building is in the form of a hemisphere. From inside, it was whitewashed at a cost of rupees 4,989.60, and if the cost of whitewashing is rupees 20 per square meter, find the Roman number 1 inside surface area of the dome, and Roman number 2 volume of the air inside the dome. So exercise 13.8, question number 8, solution. Roman number 1. In Roman number 1, we have to find the surface area, inside surface area of the dome. So inside surface area is equal to the total cost divided by the cost per meter square. So the total cost of whitewashing inside the dome is rupees 4,989.60, and the cost per meter square is rupees 20. This will be, the unit will be meter square. So dividing this 4,989.60 by 20, we will get 249.48 meter square. So this is the surface area of the inside of the dome. Now let us find the volume of air inside the dome. That is solution for the Roman number 2. So to find the volume of the air inside the dome, let us first find the radius of the dome. So let r meter be the radius of the dome. Now then, this is the inner surface area of the dome. As you know, the dome is in the shape of a hemisphere. We will use the formula for the surface area of a hemisphere to find the radius of the dome. So the formula of surface area of a hemisphere is given by 2 pi r square, which is equal to the surface area of the dome So this will be equal to 249.48. This implies 2 into 22 by 7, the value of I is 22 by 7, into R square equal to 249.48. This implies R square equal to 249.48 multiplied by 7 divided by 2 into 22. Simplifying this, we will get 39.69. This implies R will be square root of 39.69, which is equal to 6.3. So the radius of the dome is 6.3 meter. Now the volume of air inside the dome will be equal to the volume of a hemisphere with radius 6.3 meter. So the volume of a hemisphere is given by 2 by 3 pi r cube. This equal to 2 by 3, the value of pi is 22 by 7, into the value of r is 6.3 cube. This will be meter cube. After simplification, we will get the value as 523.9 meter cube. So the volume inside the dome is 523.9 meter